Okay, hopefully. Now, what do you see over here? What do you see over here? Okay, in this particular part. Ah,
Same.
yeah, what do you see? Some molecules which are already polar.
Structures of molecules.
Right. Okay. If you take this case, if you take this above case, that is ionic molecules, in this case, the dipole moment of each of this independently is zero. So whether you take the first case, that is atomic polarization, or to say electronic polarization, independent atoms were neutral. Here also the ions, okay, let me say this combination of ions is actually giving you neutral situation. Okay, is giving you a neutral situation. So if you come to this particular case, okay, a each molecule is not a neutral molecule. It's a polar molecule. It's a polar molecule. Okay. Now, when there is no applied electric field, these polar molecules are randomly oriented, but this randomness is such that the net dipole moment of this group of molecules will become zero. Okay, to correct myself, I should not be calling it as random orientation, but they orient themselves in such a manner that the net dipole moment is zero without any applied electric field. Okay, without any applied electric field, the net dipole moment of these polar molecules is zero. Okay, and when you have applied electric field, what happened here? When you applied electric field, what happened?
The position
5.
change.
Yeah, what happened?
Its position
They are
changes.
arranged in specified manner.
Good. They are arranged in specified manner. To arrange them, what do you do? To arrange them, what do you do? Okay, for example, if you have okay, this kind of objects, okay, this kind of okay, L-shaped objects or V-shaped objects, okay, and you have to arrange them like this. Okay, they are placed randomly like this on the floor. So if you have to arrange them like this, what do you do? 5.
We'll move them.
Huh?
We'll move them, sir.
Okay, how do you move? Okay, to the left or right?
The left ones to the right and the right ones to the left.
Answer is wrong. Okay, I mean, I understood what you wanted to say, but the way you have answered is not right. Yeah, Chepama, how to arrange them? Okay, in this, okay, in the order that you have on the right side. 5, 4, 3, 2, 1.
Electric field.
Yeah, upon applying an electric field, okay, they are getting arranged. But what is happening to the independent molecule? What is happening to the independent molecule? 5, 4, 3, 2, 1. They are orienting themselves in the direction of the applied field. What's happening?
They're orienting themselves in the direction of.
Okay, you people are not happy with my answer, but I don't have any other go. Okay, what is this polarization called? 5, 4,
Molecular polarization.
Molecular.
no, no. 5, 4, 3, 2, 1. What do you call this polarization? 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. 5, 4, 3, 2, 1. Orientational polarization. What's the answer? Orientational. That is why I had to use that word. Okay, sir, it could be anything now. Rotation, anochu, even anochu. Why did you use orientation? Okay, were we wrong? I'm telling you, I told you on the first day. Okay, your answers are not wrong at all. Okay, only thing is they may not match with what I want. That's the only difference. Okay, why? Okay, sir, then why do you want particular okay words only? Because that is the convention they are using in the textbook, so we have to use so that the other person who reads our answer understands it. That's the convention. Okay, okay, beauty of the physics kaada akkada. Only words and convention akkada ante. Okay, so here the molecules are orienting themselves in the direction of the external electric field to create net polarization, okay. So this kind of polarization is called orientational polarization. This kind of polarization is called orientational polarization, okay, right. So first one was because of the motion of electrons within an atom, we call it as electronic polarization. In case of the second, the ions are moving, ions are getting displaced, okay, so we call it as ionic polarization. And in the third case, the molecules are rotating themselves or orienting themselves as per the external electric field, so we call it as orientational polarization, okay. Now the last one is called space charge polarization. But what you see over here is interfacial. Okay, the word that is being used is interfacial. Whether you use interfacial polarization, okay, most of the times, okay, people may not understand the word, okay, interfacial polarization. But word and meaning, inter, between, facial, faces, that means edges. Interfacial polarization, that means polarization that is occurring between the faces, or to say edges, or at the edges. That is what you call it as interfacial polarization. But this is also called space charge polarization. Why? Because the charges which are distributed in this particular region are themselves moving from one position to another position. Okay, this is what you call it as space charge polarization. Okay, we may not discuss anything about spatial polarization, but this is something which you use it every day in your lithium ion batteries. Lithium ion batteries, okay? In lithium ion batteries that you use in your computers or in your mobiles or okay, any electrical vehicles that are coming in. Okay, in all these cases, we have space charge polarization taking place. That means charges are moving from their position to another place. Okay. Now that is space charge polarization. So polarization takes place in four different ways. One is electronic displacement resulting electronic polarization, and because of ionic displacement we call it as ionic polarization, and because of molecules orienting themselves in the direction of the applied field we call it as molecular orientational polarization. Molecular, okay, whether you put molecular or not acceptable. So but what you call it as orientational polarization. And the last one is your interfacial polarization or space charge polarization or space charge polarization. Now this part is not there in our syllabus. This part is not there in our syllabus. Okay, but this figure is very important for electronic and communication engineers. So we are not going to be electronic and communication engineers, but let me tell you, okay, now if at all if you are going for any higher order research or higher order work in any of your fields, okay, you cannot have that kind of luxury. That means you cannot say, okay, I cannot take that or I cannot take this, okay. You have to learn everything, okay. That's a different thing, okay. That's a point I want you to understand. So just keep it in mind, okay. If it okay, go through it, and if you have any doubt you ask me, we'll discuss it in our later class, because this is not in our syllabus. Okay, now how many different mechanisms of polarization are there? Yeah, answer the question. How many mechanisms of polarization are there? 5, 4, 3, 2, 1. What's answer?
Four.
How many polarization mechanisms are there? How many?
Four.
5.
Four. Four.
4. Answer is 4. Can you please tell me what are they?
Due to the displacement of electrons.
Good.
Second one is due to the displacement of ions.
Yeah, excellent.
And third one is due to the orientation of molecules.
Yeah, good.
And fourth one is
Okay, right. I understand that you get struck, okay, because already you have used the displacement of ions in ionic polarization, okay. Here, the displacement is not a very small displacement. In the last case, the displacement is not small, okay, small, okay. It moves from one end of the object to the other end of the object, and okay, very large displacements take, okay. Now, in the first case, okay, in the ionic, okay, in the ionic polarization case, the displacements are atomic scale displacement. That means displacement in the range of bond lengths, in the range of the bond lengths. But in the last case, okay, in this case, the displacements are in the range of the atomic lengths. But in this case, the displacements are very, very large. Macroscopic ion displacement. Macroscopic ion displacements. Okay. Now that's why, okay, this is called space charge polarization. That means, okay, charge in one particular, from one particular space is going to another particular space inside the material. So we call it a space charge polarization, or, okay, interfacial polarization. Anyway, good. All right. Now, okay, uh, this is another okay, extended example for space charge polarization. This is what happens. You can say in a material because of space charge polarization. Okay, this okay. Please remember. Okay, this is an uncharged battery. You can say, okay, lithium-ion battery. Okay, this is charged lithium-ion battery. Okay. Now, if you observe carefully, okay, please observe, okay, these two figures and try to tell me one important aspect that is occurring there. 5, 4, 3, 2, 1. What is the important aspect that you see between the left hand side figure and the center figure? 5, 4,
Positive and negative
3,
charges are
2, 1. Yeah, 4.
sir in the right hand figure.
Right. Yeah. What
Right.
happened?
Of ions,
Amma?
drifting of ions.
Okay, which ions are drifting? Negative ions or positive ions?
Positive towards the negative, sir.
Beautiful. Okay, so please understand it is already written over here. Okay, negative ions are fixed and the positive ions are mobile. Okay, you have learnt in your chemistry that cations are smaller in size and anions are larger in size. Antena? Yes or no?
Yes, sir.
Anyway,
Yes. Yes,
positive
sir.
ions are smaller in size and negative ions are
Yes.
larger in size. And this is, okay, whatever you see over here, this is called the crystal lattice, okay? Now, this may not be a perfect crystal lattice, but this is a crystal lattice. And you have these positive charges dispersed throughout the crystal lattice. But when you apply an electric field, these charges are, okay, these positive charges are displacing themselves, but not the negative charges. So, okay, the negative charges are the crystal lattice ions which are fixed in their position, but the positive charges are moving from one region to another region. This is what you call it as space charge polarization. That was what I was trying to explain in the previous case. Now these ions you can say are lithium ions in a lithium ion battery. Okay, and when you charge it, all these medium lithium ions come to one side, and when you use it, okay, slowly these lithium ions go back, okay, get away from the negative charge, so you'll be getting the energy because of those motion. Okay, another point, okay, this is a material, and when you apply electric field, okay, one side of this material is getting okay, positively charged and negative side, and this is called space charge polarization. Okay, or to say facial polarization, polarization that is occurring at the face, okay, or interfacial polarization, okay, and this is occurring at the edge of a grain. What is this grain, sir? Okay, grain is one particular particle in a material.